Chapter 9 introduces the concept of torque. So equilibrium is when the sum of the forces equals zero. There's no acceleration. We have two conditions represented here. In the first figure, we have a boy standing on the ground, and he's not moving. He's stationary. This is a case of static equilibrium. Sum of the forces equals zero. Acceleration is zero. So gravity pulls down on him, and the ground that he's standing on pushes up on him with a normal force. Those forces then will be equal and opposite. In the second case, we have a car traveling at a constant speed. So even though there are a number of forces here, again, all the forces add up to zero. So there's no acceleration. But because it's moving, this is called dynamic equilibrium. Now the question comes up, is this all we need for equilibrium? When I have sum of the forces equals zero, is that all that's necessary for objects to be in equilibrium? Well, let's take a look at another situation. In this figure, I have a hockey stick lying on a piece of ice. So this is a top-down view. In the first picture, we have opposing forces, equal and opposite forces, and they're in line with each other. So in this case, there is no acceleration and there's no motion. In the second case, we've offset the forces so that they don't line up with each other. Now we still have equal and opposite forces, but in the second case, there will be motion. There will actually be an acceleration. It's a rotational acceleration.